Well, hey everyone, and welcome to another episode with your girl Audrey Codner from ACG Math Tutoring. Hopefully you guys are having an awesome day. I cannot believe that it is May the 8th, and some of you guys are on the 9th if you're in Australia. But still, this is crazy. Days are flying by. Alright, so I was helping a student today. And she was kind of working on the asymptotes and also domain of those rational functions. So we did a little bit of work with rational functions before. So just to refresh your memory, rational function, if I said the f of x, or even if I said y, but let's say since we're dealing with functions, it'll be f of x, and I have x squared, okay, minus 1 over x. Okay, so this is a rational function because basically my numerator and my denominator both contains what's called polynomials. This is a monomial, this is a binomial, altogether it's a polynomial. All right, so when we're looking for the domain, and we've heard about domain when we're dealing with linear equations. So now we're looking at basically the set of, here we go, the denominator to 0. So we're going to make it equal to 0 and we're going to solve. And we're going to figure out what points or what areas, okay, what is the value of x that is basically making my denominator equal to 0. So if you know anything about fractions, we do not want to have a 0 in the denominator because that makes it what? Undefined. So we don't want to have our fractions undefined because sometimes that will cause us to have a limitation, a boundary line, a asymptote, as we might say. All right? So when we always look at this, every time I see a fraction, I always like to say no O below. Okay? We do not want to have a 0 in that denominator, but we need to figure out what is that number that's going to make it into an undefined situation. So the only thing for this particular one that can make it undefined is going to be 0 itself, right? So we're looking at our domain. Our domain is our list of x values. So our list of x values that will satisfy that fraction, right? So we're basically saying, hey, this domain could be all real numbers. Ever see this symbol? If you ever do, that's what it's called, okay? All real numbers, except for it cannot equal 0. So I can put any number except for 0 to satisfy this fraction or function, because the 0 is the only thing that's going to make it into an undefined situation. So since we're basically saying, if I were to graph this, I'm saying that, hey, if I ever get close to x equals 0, coming from the left side or from the right side, I forgot my camera's not mirrored right now. My regular camera is usually mirrored. That's why I was like, coming from the left side, I'm like, wait, we're not mirrored right now. All right. So if I'm coming from the left side or coming from the right side, no matter what, my function will never, especially the denominator, will never equal 0. So that is going to be a boundary. And if you think about the type of line that's going to come through only through the x-axis, is a vertical line. So since it's a vertical line, we're basically going to put what's called an asymptote. Asymptote. Or tote. All right? So your vertical asymptote is going to be, let me slide over, x equals 0. So basically, the same number that's going to make this undefined is going to define what our vertical asymptote is. All right? All right. Hello. Oh, okay. Oh, how'd it go? How'd your test go, Cora? I was like, do I do polynomials? I do polynomials. I'm working on domain and asymptotes tonight, but I do polynomials. All right. Okay. Oh, thanks guys coming on in. All right. So I want to, just for right now, going to give us a couple situations, and I just want us to define what the domain is and what the vertical asymptote is. So I'm taking this whole concept of asymptotes step by step. All right, so it's not too overwhelming with everyone. Okay, Sullivan, you have your final on Monday. All right, you're gonna do fine if you keep with the practice, okay? Keep with the practicing. All right, so let me give you another example. Let me switch colors as best I can, and hopefully it will show up. So we got our example. Okay, not too bad. So if I have x plus 1 over x plus 3. And I know I really should have my f of x involved in this, just to keep with the theme. All right? Just to keep with the theme. All right. Oh, thanks, Chris. All right. So we want to get just right now, just the domain and the vertical asymptote. I'm going to work on the other asymptotes in a moment. I just want to focus on that to make sure you got that down. So when you want to figure out your domain and your vertical asymptote, you need to go straight to the denominator. And you need to figure out what number is going to represent x to make my denominator into an undefined situation. AKA, make your denominator equal to 0 and solve for x, right? Sometimes people are just like, oh, let's do an elaboration and all the... People, just get right straight to it. So if I look at my domain, I want to first, I always like to set up my VA, my vertical asymptote. So my vertical asymptote is basically the denominator equal to 0, and I want to solve for x. All right, so I would subtract 3 on both sides. Okay, I know physically we can see it, but you know, some people like to see details. So we have x is equal to -3. So that means if I were to draw this graph, I'm going to have a vertical line, okay, vertical up and down, vertical line crossing the x-axis at -3. That's going to be the boundary, because the graph of this rational function, it can get as close as it can to that x equals -3, but it will never equal -3, because that -3 is what will make my denominator into an undefined situation. So with that being said, I can put any number at all. Doesn't really matter. I could put any number for the x except for -3. So that's when I'm coming down to talk about my domain. Okay? So my domain can be all real numbers except for x cannot equal -3. All right. Hey, Space Cadet, how are you? Haven't seen you in a minute. Hopefully you're doing all right. Oh, and thank you for the love. My goodness. Never had this when you were in school, Chris? Yes. Okay. So the horizontal asymptote, we're going to get to that. We're going to get to it. I appreciate that, but it's true. X has the same power. Yep. So you divide the coefficients. Correct. Oh, what is your name? J for Bill. J for Jafer? We'll figure it out. Okay. Not a problem. Yes, so glad that you're here. Okay, so now let us take a look at another one. Okay, so I'm just going to slide this over a little bit. So we got our next example. Hopefully make it a little bit darker so you guys can see. So we have our f of x is equal to, let me unzoom just a lot, not even a hair, just a lot. So we have x plus 2 over x squared minus 4. Okay, so this is going to be our next one. And you're struggling with algebra? Aw. I was like, look, if you have some time yeah, I think I can fit you in. If you're serious and you really need some help, just to brush up on some things, make sure you message me. Okay? Make sure you message me. So see if I can help you, okay? JV? Is it JV or Javi? Sometimes it comes out there. All right. So, Pog. Hello, Pog. Okay. You tutor? Yes, I do. Yes, I used to be in the classroom for like 22 years, and I've been tutoring for 5 years. Yep. All right. So, easiest part, I like to go through a rhythm. That's just me. So, the first thing I like to find is your vertical asymptote, your VA. So that means I'm going to take my denominator, which is my x squared minus 4 equals 0. Okay? So I'm going to solve this equation, and I want to know what value of x is going to make this equation equal 0. Okay? So a couple of you guys put it in there already, which is great. All right? Sample with no. Can you explain? I will see if I can get into that. Oh, standard deviation? Yeah, I'm not going into that tonight. I mean, it's really, once you know, it's the distance away from the mean. Once you get to figure out the mean. So now you have your x squared is equal to 4. So we want to get x by itself. What do I need to do with it? Oh, Atticus. How are you? I haven't seen you in a minute. Oh, well, everyone's coming out of the woodwork tonight. S Money is here. Whoa. All right. Carly's here. Space Cadet's here. HP is here. Hello, Carly. Okay. Lightning, you're funny. Good. Here we go. All right, Jonathan's here. Hello, Chris. TNT, Mark. Good. Yes. So in order for us, remember, the opposite of a square is not a circle. The opposite of a square is the square root. So that means the square and the square roots are going to cancel out, which gives me x. Now, since I am solving and I'm coming out of a radical, this is when you put your plus minus. Because if you remember at the very start, we had x to the second power. This is telling you how many possible solutions you should have. So I'm working on the positive answer and the negative answer of my square root of 4, which is 2. So I have a positive 2 and a negative 2. So it looks to me, any number, any real number will work except for positive 2 and negative 2. Now, excuse me. I was like, I thought I was going to be a little ill for a second. All right, so it's basically going to be like all your real numbers except for x cannot equal plus and minus 2. Yes, you could put it in the unified form. Yes, you can put it into interval notation. You can do all of that. I just want you to get the basics, okay? All right, how are we feeling? All right, thanks so much for the follows, guys. Yes, I see. All right, so now this part, I'm not sure if a lot of you guys know, but we're going to give it the old college try. And you're probably like, I'm still in high school. That's fine. Your time to advanced. So, again, we're just doing domain and the vertical asymptote. So, I'm obsessed with my 2's right now. So, I have x minus 2, and then I have x squared minus 5x plus 6. Ooh. Factor the x squared minus. Yep, you could factor it. Because, yes, Heavy D. And nice to see you, Heavy D. Yes, you could have factored it out as well. But I just wanted to keep with the same theme. Just in case. I don't want to go to all kinds of everywhere. Okay? But, yes, you can. All right. So, I get spaces that can't even speak. With a negative 6, Pog with 1 and negative 6. Okay. Thank you guys for the follow. Try to factor it out. Because unless you want to have fun putting it in standard form and then breaking it down, you can have fun doing that. All right, so kind of doing a quick review of factoring. All right, so now I'm seeing 2 and 3. Okay, Mark, I'm seeing x minus 2 and x minus 3. All right, let's see. So, knowing me, let's review a little bit with the factoring. My leading coefficient is 1. My highest degree, I'm just looking at the denominator. My highest degree is 2. So right away, I'm thinking, let me see if I can factor it. Okay, now I'm not talking about quadratic formula, just a simple AC method. So I can go ahead and split my x's because my leading coefficient is 1. Now I need to think, what two numbers multiplied together will give me 6 and add together to give me a negative 5? Well, we have 6 and 1, and we have 3 and 2. Now, I need a positive 6, so that means it could be positive versions or it could be the negative versions. Because a negative times a negative does give me a positive. But which one will add up to give me negative 5? Okay, so this is what I'm seeing. Yes. Yes, Fabian, good. It is factoring. Good. Shakita, oh, hey. So that's 2 and 3. Negative 3, negative 2. Okay, arts for you. X minus 3, X minus 2. Negative 2, negative 3. Go. The solutions are 2 and 3. All right. So some of you guys started off with the 6 and 1s, but you notice that, all right, if I add those two together, that's going to give me a negative 7. So that means we're going to put our -3 here and a -2 here. Now I'm going to repeat this every time we do factoring. It doesn't matter which one you put first. Okay? There's still going to be the same factors to make this into a true expression. All right? So now, let's take a look. What do you notice? So this is no longer a part of the situation because we got its factored cousin right below. What do you notice? Okay, why both of them are negative? Because we needed a +6. A -3 times a -2, remember a negative times a negative gives me a positive, and a negative plus a negative gives me the negative. Okay, yes, okay, so we have the top can cancel with the bottom. Yes, we have similar terms, same signs, same expressions. So we can simplify this. Okay, we can simplify this. So with that, that goes, that goes. So what comes down is what? You're welcome. Okay. By the C value. Good. Then you're left with 1 in the numerator. There you go. That's it. So 1 over x minus 3. So since we were able to factor this down, what will be my VA? Or do I have a VA? Just because I wrote it doesn't necessarily mean there's one. Okay, good. Nice Mark, nice Claire. Good job, Chris. Corrosive, alkaline. Love it. Good job. All right. How I got the 1? Sure. So we have our x minus 2, and there was an x minus 2 in the denominator. 1 in the numerator, 1 in the denominator. So when you divide those, it will give you that 1. Okay? We always have to balance out our ratios, especially when that x minus 3 is still in the denominator. There has to be something in the numerator. Okay? All right? Makes sense? Yeah. Yeah, AP Calc, I know. Yeah, your AP test is coming up soon, isn't it? All right. Are we okay now, ladies? You see where I got the 1? You can give me a thumbs up just so I know. Okay, so Chris is saying, is it all real numbers except for 3? Yes, so that will be your domain. So what is the VA? The VA is the vertical asymptote. So where would that boundary line go? Through the x-axis. So basically, where is your domain not welcomed? Let's put it that way. So it's not going to be welcome when x is equal to 3 because your domain, it could be all real numbers except for that positive 3. Okay. This is like Algebra 2. Well, it's kind of like college algebra, to be honest with you. Okay. Yeah. It's like college algebra, a little bit of pre-calc. But I'm starting to see a lot of it in college algebra. I've been doing a lot of tutoring on this lately. This is so good. My college years. Well, I'll do what I can do. I'm here for whatever can hear. Questions on this? Greater than equal to? Okay. Yeah, greater than equal to. A little pre-calc, a little algebra 2. Just a little mixture. All right. So when you do get an opportunity to see if you can cancel out. Now, for some of my, oh yes, who is in my brain? Who is this? Is this Jafar? Ooh. I'm so sorry. Is it Javi? There we go. Yes. How can you find the hole? That's what I was just about to say. Now, people are probably like, a hole? What the heck's a hole? So here's the thing. When you factor and the concepts or the expressions that you cancel out, they're saying that if you graph it, you're going to have an empty space, a hole, okay? That you're literally going to have a line and there's going to be a hole, and then the line's going to continue on, okay? Where it cancels out, that's where your hole is. I know there's so many jokes that comes to mind, but let's see if we can mature it up just for 5 seconds, all right? So it's canceling out when x minus 2. So I can, if I make that into 0, I can say my x, there's going to be a hole at 2. Or there's going to be a hole, actually, not solving, so much. There's going to be a hole, at 2. So like if I graphed it really quick as a sketch, let's go 1, 2, 3, 4, 5, 1, 2, 3, 1, 2, 3. All right, so we know that there is going to be a vertical asymptote at x equals 3. So that's my red boundary line. So if I were to graph this, that means there is going to be a hole at 2. That's right. I have to make it equal to 0. So whatever and this is the other thing, when you do have a hole, ready? There's another asymptote that is known. Okay? We have vertical asymptotes, okay, straight up and down. We have horizontal asymptotes, left and right. And then we have what's called an oblique or a slant asymptote. Now, when you have a hole, you're not going to have a horizontal asymptote. You're going to have an oblique, a slanted asymptote, which is a line. So wherever you find, we need to find that slant, okay? And I'll come back to this problem to show you that. Once we find the equation of the line of that slant, then we're going to say there is a hole when x is equal to 2 on that slanted line. Okay? Right now, I feel like I'm jumping. So I'm going to reel it on back. Okay? So, to kind of do a quick refresher, if you're given a rational function, to find the domain, you're looking at the denominator and you're setting it equal to 0. Okay? The key thing is we want to figure out what is that number that's going to make our denominator into 0. So in this case, it was 0. So that means we have a vertical asymptote when x is equal to 0. That's going to be the boundary line. Okay? Vertically, straight up and down. All right, so anytime you want to find the vertical asymptote, set your denominator equal to 0, and whatever it equals, that's going to be the restriction, okay, for your domain. So whatever the domain shouldn't be, that's what your vertical asymptote is. Make sense? Feel like I'm killing it, I know. No, you don't lose the VA. You don't lose the VA. Okay, all right. So that was vertical and domain. Now we're gonna go a little bit more. So get your cameras ready. If you want to tap a little bit, you can tap. Everything is going. Yep, you can solve almost any problem. I know. And that's the one thing about math. It keeps evolving. Once you know the basics, everything else progresses. I'm going to try to put everything in one, but I think I'm going to really focus on the table first, and then I'll slide over. Okay? Okay. Thank you. All right. So, we have two different asymptotes going on here. I'm going to go one box at a time so you can see. So you don't feel like you're in the nosebleed seats of a baseball game trying to figure out, all right, is that the pitcher? Like, instead of going all that. All right. So the next asymptote we're going to talk about is horizontal asymptote. Now, the easiest way to find your horizontal asymptote, it's all based on your degrees. It's always based on your highest exponent. All right? So, not a problem, man. This is not GED. This will be college algebra. So people that are taking those intermediate classes. So yes, this is not going to be GED. So you can breathe. Nicole, she's like, oh, thank God. All right. So horizontal asymptotes. If the degree n is the numerator, d means denominator. So if your degree in the numerator is less than the degree in the denominator, your horizontal asymptote will always equal 0. So basically your x-axis is playing the horizontal game. And if you graph it, it will get as close as it can to that x-axis, but it will never cross it. All right? So, for example, if I had 2x squared over 3x to the 5th, my numerator is smaller than my denominator. Okay, so that means my horizontal asymptote is automatically y equals 0. All right. Okay, so screenshot that bad boy, or you're going to have it in the next upcoming Audrey's notes. All right. So now for the next one, horizontal asymptote. So when the degree of the numerator equals the degree of the denominator. Okay, someone mentioned it earlier today. Or tonight. Someone mentioned it earlier. I have to scroll it. You're basically taking your leading coefficients of both the numerator and denominator, and that is going to be your horizontal asymptote. So for example, if I have 2x squared divided by 3x squared, notice my degrees are exactly the same. So that means I'm just going to focus on the leading coefficients. So that's why my horizontal asymptote is going to be 2 over 3. Okay? You see how it's basically, You see how it's basically what is going on with your highest degree. Even if they have the degrees all mixed up. Let me take this on the side piece of paper just real quick. Okay, so if they had like 2x to the third plus 5x minus 7x to the fifth plus 4. I know the handwriting is horrible. I was just doing a really quick sketch. What is my leading coefficient? Let's put that into the chat. What is my leading coefficient? Okay, Pog is saying -7. Do we agree? And you can use question marks if you're not sure. That's an answer as well. Okay, that's definitely welcomed here. I know the handwriting is really rough. Sorry. Okay. All right, Alex, thank you for your truth. Thank you. Okay, Nicole saying -7 to the fifth. Candy girl, how are you? -7. Awesome. Get rid of those question marks. Good job, girl. All right. So it's going to be, yes, thank you, DM. Appreciate you. All right. So it's going to be the -7. And the reason why, it has the highest exponent, aka the degree. So you always, regardless, everyone says leading coefficient, they want to say, oh, it's the first number of the polynomial. Not necessarily. Okay? Because sometimes the leading coefficient is going to be back here or in the middle or maybe at the end. Okay? So no matter how it's rotated around, your leading coefficient, I'll straighten it out a little bit. So we got -7x to the fifth. Then the next one is a positive 2x cubed. Then it's plus 5x. Then it's plus 4. Obviously, I just threw it together. Okay? So my highest degree is to the fifth power. And my leading coefficient, that's what I'm using LC for. My leading coefficient is -7. Okay? So the way that we can tell the horizontal asymptotes is when you're looking at your highest degrees, basically, and your leading coefficients. So when the degree is smaller in the numerator than in the denominator, your horizontal asymptote, boom, automatically y equals 0. But if they are exactly the same, that means we're looking at the leading coefficient, which is my 2 and my 3, and that fraction is going to make up my horizontal asymptote. All right. What topic is this? We're basically finding domain, which we did that part, and now we're working on the different asymptotes of rational functions. Okay? It's basically like Algebra 2. Algebra 2, a little bit of Pre-Calc. All right. Okay. I can use, well, right, not a problem. I know, I have some courses and I'm developing something over the summer, so just stay tuned. I'm going to keep telling you all this stuff. And then plus I have my notes for sale, so if you ever want to buy the notes, you can. All right. Right after radical expressions, yes, you will. Yep, right after radicals, that's rationals coming right around the corner. Yeah, I used to have trouble with algebra until my teacher told me that the x could be any number or anything. Yep, the x crystal. Oh, crystal. Yes, the x can be anything. It's the number in front. Every time they say, oh, if you don't see a number, like, oh, x is 1. Like, no, x isn't 1. The coefficient of the x is 1. All right. So now, the last. So we know vertical asymptotes. We took a look at horizontal asymptotes. But what happens if the numerator, the degree of the numerator, is bigger than the degree of the denominator? We're not going to have a horizontal asymptote, okay? When in fact, we're going to have what's called a slant or oblique asymptote, okay? So when you're dealing with that, you actually have to divide those two, your numerator and your denominator. You're actually going to have to do division, either long division or synthetic division. But here's a key thing, which is right here in the little crook. Okay? Once you get your number, you ignore the remainder. You don't need the remainder, because what you're trying to do is get the equation of the line that makes up your slant, because slant is either going up as positive or down as negative. Okay, so we're kind of bringing back the equation of the line, okay, to define your slant oblique. So that's when the degree of the numerator is larger than the degree in the denominator. All right. Okay. So lots of stuff going on here. Okay. Lots of things going on here. But there's a couple of the things that I think I mentioned earlier, but I want to bring it on back. Just some key stuff. Yeah, I went to college and all I could come up was key stuff. But anywho, it says, here's a key thing. All right. You can only have a horizontal asymptote. Okay. That's these two. Or a slant. You can't have both. Okay. You cannot have both a horizontal and a slant. You're going to have a vertical. Okay. You're going to either have a horizontal or a slant, but you can't have both at the same time. Now, here's the thing. Remember we were talking about the holes back in the other page? Holes is going to come in connection with your slant. Okay? You're not going to see any holes. Kind of emphasize that. HOLES. When you're dealing with the horizontal asymptote. Okay, most of the time you're going to see it with the slant. Okay, most of the time you're going to see it with the slant. All right. Okay. All righty then. So let's do some practice. Let's just stop hammering on and let's see what we can get out of here. All right. So. I don't think I want to do that one, but I could do. All right, so let's put it all together here. Let's see, where are we here? So if I put 3x over, let's say 2x minus 1. Okay, let's start off. Let's start off nice, and I don't want to say easy, but just nice. Let's start off nice. All right, so let me zoom in just a hair. All right, so we have 3x over 2x minus 1. So let's start from the beginning. I want you to tell me what my VA is. I want you to tell me what my domain is. And if I'm going to have a horizontal asymptote or a slant asymptote. I'm just going to write the word slant. Okay, and then what is it? All right, so walking yourself easy. What will be the VA? Let's start with the VA first. The VA is your vertical asymptote. And if you're not sure, like you just came in, you can be silent. You can use a question mark. Hey, well, if you don't know, I will definitely go over. I will go over problems, what needs to be done. You tell me. You tell me. Okay, thank you for the follows, guys. Early part of the slant. Okay. How do you know it's a slant? You know it's a slant, I think. You're like, yeah, wait, I don't know. You had that fluctuation in your voice. That's what made me stop, Audrey. It's okay. It's okay. I always have fluctuations in my voice. Okay. If you're not sure, put question marks. Trust me, it's not Squid Games, guys. I'm not gonna off you, you know? The numerator is higher. Okay, the numerator is higher, but is the degree in the numerator higher? Okay, so Ruben's saying when the exponent in the numerator is greater by 1 in the denominator. Okay, is it, or is that what you're asking? Right. Okay, Nicole, thank you for your honesty. Appreciate that. Okay. Oh, thanks for the love. Appreciate it. All right. Okay, so let's walk it through. So the VA, okay, especially for those that came a little bit later. So the VA and the domain, you automatically look at the denominator. Okay? Automatically look at the denominator. So your VA is when you take this denominator, which is 2x minus 1, and you set it equal to 0. You want to know what is going to make our denominator equal to 0, because that's going to make it undefined. Remember, an asymptote is a boundary line. So like things will get as close as it can, but it will never cross it. Okay? So you want to know what's going to make that denominator equal 0. Yes. So we're going to add 1 to both sides. So that gives me 2x is equal to 1. What would x equal? I'm going to try to squeeze it over here. If 2x is equal to 1, what would x equal? Go ahead, put it in the chat. What would x equal? Hello, Michael. How are you? Good. Yes, at a decent time this time. My gosh, last night was too much. Good. All right, so we have JFC, all of those letters. Okay, saying 1/2. Okay, Ruben saying 1/2. Candy Girl saying 0.5 with the 1/2. Okay, stall it. Hey, Shay. Yes. So if we divide both sides by 2, we'll get x is equal to 1/2. So this, I know, right? So this is going to be your boundary line. This is going to be your vertical asymptote. Okay, the line will get as close as it can, but it will never cross. So that means for my domain, I can use any number whatsoever. Do you see a pattern with the domain? Have you guys picked it up? So basically it could be all real numbers, any number except for what? Okay, it could be any number except for what? This is 0. Mm-hmm. No, not 0. The 1/2. The work that you just did for the vertical asymptote is the same thing that you're going to get for the domain. Because if I plug in that 1/2 for the x value, half of 2 is 1. 1 minus 1 will give me that 0. So this 1/2 is going to be the troublemaker. that's going to make all this go to 0, right? Any other number that I plug in, if I plug in a 4, I get 2 times 4 gives me 8, minus 1 gives me 7. That's perfectly fine. I can plug in, I don't know, trying to think of something I can't think on the fly. So I can think of, well, other than 1/2. If I wanted to say 3/2, okay, so that'll be 3/2 of 2 is 3. 3 minus 1 gives me 2. That's perfectly fine. But if I plug this 1/2 in for the x, it's going to make it equal 0, which will make this rational function be undefined. Okay? So we're looking for what will make it equal to 0. So now, I want to know if it's a horizontal asymptote or a slant. So the way I can tell is look at the degrees. What do you notice about the degrees? Let me lower this down a little bit. What do you notice about the degrees? Okay, the degree in the numerator and the denominator. So you just do this for funish. Oh, well, thank you. Yeah, funish. Sometimes I use what my current students are struggling with, and I figure someone else is probably struggling with it. So, boom, here we are. Yeah, they're the same. Good, the same. That's it, Ruben, Michael, Pog. Yes. Beckett. Yes. Okay. Negative in the denominator. But also look at the degrees. The degrees are exactly the same. Okay. So when you get with the degree exactly the same, let me slide on down. Let's take a look. Okay, this is when it's saying the degree of the numerator is less than the denominator. Well, that's not it. It's saying when they're the same. Okay, so when they're the same, we got a horizontal asymptote. And how do I find that horizontal asymptote? I take the leading coefficients of both the numerator and denominator to make it set equal to y. So in this case, we have 3 over 2. Since both of my exponents are the same, 1, we have a horizontal asymptote. So that is going to give me y equals, and the coefficients, which is 3 over 2. Okay. Okay, I'm going to do graphing another day. I just wanted people to get ideas. I do not want to completely overwhelm. There's plenty other platforms that can tell you and do things so much better than I can. But I don't like to overwhelm on this platform. Okay. All right. So we can just leave it as a fraction. We don't have to turn it into decimals. Okay. All right. Let's try another one. All right. So let's say. I want to challenge. I want to challenge. Okay, let's try this one. Let's try f of x, which I gotta remember to put down. So f of x equals x squared minus 6x plus 9 over x plus 1. So what I would like is the VA. I'm going to give myself a little more room this time. So I want the VA. I want the domain. And then I want to know, is it horizontal or slant? Okay. So although I'm not graphing tonight, if you ever want to, you can create a table of values. So if you pick, like first you know what your asymptote is, and then you can pick some points to the left and you can pick some points to the right in order to graph it up so you can see it. Okay. All right. So Pog is saying my VA is -1. Okay. Candy Girl saying it's -1 with a slant of 3. Slant might be a little difficult for those that are my normals. Well, not all of them, but a good majority, which is fine if it is a slant, but I think it is. So let's go through it, okay? So my VA and the domain, you always go straight to, the domain, you always go straight to the denominator. So for the VA, you want to set that denominator equal to 0. We want to know what number is going to make that equal to 0, which you can subtract 1 on both sides, which will give us x is equal to -1. So we're saying that my domain can be all real numbers except for my -1. Okay, so what would make our denominator equal 0 is going to be that restriction that we have for domain. So it could be anything else except for that. Okay, now horizontal asymptote or slant. So that means I am going back to the degrees. This is a degree of 2. This down here is a degree of 1. So if I come back up here, okay, this one says when the numerator is less than the denominator, but that's not it. It's not equal either. So we definitely have a slant. Okay, yes. All right, so that's how you tell that you have a slant. You're looking at your degrees. If your numerator is larger than your denominator, you got a slant. So in order for us to figure this out, we're not going to have a y equals what? We got to divide. We got to divide the numerator and denominator. You're going to get a line instead of just, oh, y equals this, okay? You're basically looking at a y equals mx plus b type of situation. So you're probably like, oh, well, Audrey, how are we going to divide this? Okay, we can do this one of two ways. We can either do long division, which would be no, or we can use synthetic division. Okay, someone at one point asked me, what's the point of synthetic division? It's just, I'm like, trust me, you're going to be like, thank God for synthetic division sometimes. Okay, So the way synthetic division goes, so I am looking at, let me help you guide your eyes a little bit. I am looking at this rational expression, okay? This is my divisor, this is my dividend. So if I want to do division, I'm going to take the opposite of what I see from my divisor. Okay, so I have x plus 1. The reason why the original formula has it as x minus h, if I'm not mistaken. So if the original is a minus and we got a plus, what happened with that minus sign to turn it into a plus, that means that h value was originally a negative number. Because a negative times a negative gives us a positive. So the easiest way that I like to say it is always do the opposite of what you see. I think this is a K, not a H. Sorry, thinking about vertex form. All right, so you always want to do the opposite of what you see. So this is going to be a negative 1. This negative 1 is going in what I call the box. Now up here, we're going to take the coefficients of each term. So in front of this x squared, we have a 1. Here's my 1. In front of the x, we have a negative 6. Here's my minus 6. And the constant is a 9. It's not even in front of anything. Okay. Never heard of synthetic? Ooh, trust me. Yes, this is fun. All right. So now, what happens, and we're going to follow step by step. I might have to do another thing on synthetic division or long division. First step, the first number is going to come down. Okay, the first number always drops down. Now, what happens next is you're going to multiply what's inside the box to what's down below in this row. So we have negative 1 times 1. Negative 1 times 1 gives me negative 1. I'm going to put my answer underneath the next one. So this is answer. Goes here. What I do from here is I'm going to add these two together. So negative 6 plus a negative 1 gives me a negative 7. Okay. Now I'm going to repeat the process again. Negative 1 times negative 7 gives me a positive 7. That positive 7 goes underneath the next term. Then you're going to add them together. Okay, 9 plus 7, that's 16. Okay, so your divisor, which was this x plus 1, do the opposite what you see, so it'll be a negative 1. Then you write the coefficients of your dividend. That's your 1, your negative 6, and your 9. The first one comes down. You multiply, negative 1 times 1, put your answer in the next form. Add together. Multiply, next one, add together. So now, this part is when it gets fun. This was originally our x squared. This was our x, and this was our constant. This is basically your answer. You always want to do one less. So you have 1x. Now this is going to be my constant, minus 7. And that means the 16 is my remainder. So just like I mentioned before, ignore the remainder. Okay? Ignore the remainder. What you found is the equation of that line of your slant. Okay? It's your slant or your oblique. So all of this is happening because the degree in the numerator is larger than the degree in the denominator. So you have to divide them up, and you can use synthetic division to kind of get through it the same way. Okay, I'm more than willing to show you guys the long division if we need to. Just let me know, put it in the chat if you want me to do that. Yes, I know, right, Carly? It's like sunshine and rainbows. That's why a lot of teachers like hold off until the end after you tortured yourself with long division, because a lot of you guys don't learn long division in your classrooms. All because once this was introduced into the classroom, right? Once this was introduced into the classroom, division and multiplication went out the window, right? So, I know. Practice tomorrow. Oh, okay. Oh, you're going to be fine. Now, just take it step by step. Okay, remember, it is not the end of the world. If you pass it, awesome. Great. Move on. Be a great teacher. All right? But if you don't, just take it again. Hell, I took the practice 11 times. I'm not going to sit here and lie to you. 11 times. And that was like over 22 years ago. Yeah. So, I would love learning new things. Oh, okay. Well, good, Candy. All right. I think we got everything in here. Oh, except for one thing. How about circling slant, Audrey? Just to show that it's going to be a slant. All right. Let's see if we can do one more. Oh, good. I know I wasn't. I wasn't always good at math. No sirree, Bobby. All right. No sirree, Bob. All right. Let's see what we can do. We can. All right. We can do this one. And I'm going to squeeze it right in here as soon as I can find my pen. That is not that color. Okay. So, last one. I must be doing very well because Michael didn't say one more. Must be doing some work. All right, so we have f of x is equal to x squared. Now, for those are relatively new with the whole algebra concepts, f of x and your y is the same. The only reason why I'm using f of x is because I am talking about a function. Okay, just like how your y's are your dependent variables, they rely on the x's. So basically your y's is a function of your x. Yeah. The hole is where the asymptote line intersects the graph. I don't know if I want to say it that way, because if you have a asymptote, there is no intersection. So that's why I'm just very hesitant to say that, because no. Okay. Yeah, so that's why I like Pog. I don't want to say the whole is on the line, but the whole is either sometimes is on the line, but it's not crossing the asymptote, if that makes sense. Because it can't cross, you cannot cross the asymptote. It's almost like me trying to, like a solid brick steel wall, like that fork knocks, and I'm trying to just, let me see if I can break through this. No. Okay, so that's where it's almost like you can get as close, you can lean up against that wall, without being tased, but you can, if so, you can lean up against that wall, and that's as far as you can physically go. So that's almost like what an asymptote looks like. You can get as close as you can with it, but you won't be able to break through it. Okay. All right. So, tell me what you want. Okay. Tell me my VA. Tell me my domain. And if we have a horizontal asymptote or a slant, and tell me what it is. Okay. All right, we'll put that right there. Okay, is the first -3 or -1? I'm trying to think. -3 or -1? Kind of curious. -1x cubed? Kind of curious. I got -3s, -1s. Oh, we are wrapping up, but we're learning on finding the domain and the asymptotes of rational functions. So how would I get rid of a cubed? Yes. Okay, look at the denominator and do what with the denominator, Nicole? Ooh, Kate, you're close, but not the square root and not the square. What will cancel out a cube? I know, I'm being evil. Sorry. Sorry, not sorry. You're thinking, though. You're thinking. Yes, Michael. There we go. Look at Pog. All right. All this advancement. Okay, let's take a look. Okay, you're thinking. I love how you guys are thinking, though. All right, so don't be like, oh, I'm stupid. I don't know how to do this. Dude, some of you guys probably have never seen this a day of your life. All right? Again, you're not going to come out the womb breakdancing. No, you're trying to figure out what the hell is that. Oh, it's my finger. Okay, so baby steps. Give yourself some grace. All right. So in order to find the vertical asymptote and the domain, we got to look at our denominator. So we need to set this denominator equal to 0. So that's x cubed is equal to 0. So if I want to get rid of the x cubed, I have to do its inverse. And the inverse of a cube is a cubed root. And if you guys haven't gotten to cube roots yet, it's coming. All right? So the cube and the cube root, they cancel each other out, leaving me with x. Now, since it's a cube root, all right, we don't put a plus minus. Plus minus only goes for squares and square roots, basically. But we got the cube root of 0. So 0 times 0 times 0 gives us, what is carry the 5, to sacrifice a chicken? It's 0, okay? All right? So x is equal to 0. Yes. All right? So if your vertical asymptote, so that is going to be your line where it's not going to cross. And I'm looking at my domain, which is, shocker, it's all real numbers except for what? Okay. Yes, good. Is that NY? Yeah, Lacole, good. Kai, K or Caden, good. Cannot equal 0. Okay? So the VA is telling you what is your boundary, and the domain is going to be all real numbers except for when x equals 0, because that 0 will make that denominator equal 0, which will make it undefined, and we don't want that. All right, so now, is it horizontal or is it slant? Okay. Ooh, we got a battle. Is it Pepsi or is it Coca-Cola? Which one? Who's going to win the taste test? How come they don't have taste tests anymore, right? They don't do that. They need to bring that back. Free samples. So we got horizontal, we got slant, we got horizontal. We got neither. Dr. Oh, I know. See, Michael? That's why we're besties, man. You can tell I'm hyped up right now because I definitely had a 0. I don't know why they call it 0 sugar, because I am amped. DP this afternoon, so I'm like, yeah. All right, so horizontal, since the denominator is greater. Look at Candy Girl. I'm probably wrong. Well, let's have some Fanta. I've never really been into Fanta. Yeah. I know, it's weird, right? Okay. So, Sprite. I know, what is that new Sprite that's coming out? I don't even know. Somebody created something to poison us further. All right? But take a look at your exponents. Take a look at it. Look at it. All right. Okay. I was on this stuff and we never covered this topic. Aw. Wait, your final was on this stuff and you never covered the topic? See, that just agitates my soul. It's called, hopefully he's not, or she, whoever, is not gonna grade it, because I will fight that to the death. I mean, seriously, I'll be like going after Khan big time. All right. Oh yeah, I would definitely fight it, Virgo. Hands down. Because you can't take an assessment on something that you were never instructed upon. Unless he or she can prove that, yes, we did mention it and maybe it was a day that you were absent. That happens. But if you've never Yeah, that should not count against you. All right. What's the rules again? Sure. Let me flash them up. So if the numerator, the degree of the numerator is less than the degree in the denominator, if the degree in the numerator is equal to the degree in the denominator, and if the degree in the numerator is bigger than the degree in the denominator. Which one? This is like Algebra 2, a little bit of Pre-Calc. I'm starting to see this in college algebra too. So, all right. Yes. So what we have since this, yes, it's going to be a horizontal asymptote. Now, since my degree is lower in the numerator than the denominator, and it's a horizontal asymptote, that means my has to be y equals what? Horizontal asymptote, y would equal what each and every time? Yes, and y represent. Is it Zamir? If it is, good job. Nice. All right, cool. I know, I like to get people's names correct. There's a lot of power in names. Okay, nice. All right, so we did something a little bit tougher. Not too bad, not too shabby. How you feeling? Oh, look at this, 7K, nice. How are you guys feeling about this? A little okay? Do I go over calculus, NY? That is not my jam. But if you need a tutor, I got a guy. I got a guy. The only reason why I'm dabbling, because those integrals and the chain rule and the derivatives I'm good with. Derivatives I can do. Limits, yeah, all right. But the blessed chain rule and the product rule and the quotient rule and this rule and that rule. No. No. It's just not my jam. Yeah. But if you do, go ahead and just message me if you're serious about, like, I need somebody. You might be coming up on your final exam. Just let me know, because I do have a guy that he lives for this stuff. He loves calculus and AP statistics. And it doesn't matter what kind of calc it is. It could be Calc AB, Calc BC. He's all about that. Okay? Yes, not a problem. Not a problem. So I'm like, this is basically what we did. So we worked on domain. So we got the domain and the vertical asymptote. Okay, we worked a little bit with the horizontal and the slant asymptotes. There is another step, but we're not going to get to that tonight. Well, I don't want to overwhelm too much. I want to build you up. Now, if you like the structure of my notebook, I created this lovely thing. And also, I am going, my notes are for sale. So right now, this is book 3, and book 3 is going to be done in probably by next week. So then I'll have book 3 on sale, ready to go. So you can use these notes. And what I do is I'll take a page. Let's say here's a page. And then there's a QR code that goes directed to the live that I created the notes from. So now you don't have to go like, okay, which live is it? Is it this live? Is it that live? All you have to do is just scan the QR code or click the link, because I try to keep the active links on there. To click the link, and then boom, you'll see everything. Okay, and then you can follow along with the notes. So if you want to do that, yeah, just reach out. It's definitely on my website. My website is inside my profile. Oh God, no, I do not. I do not whatsoever. Yeah, no, that's not my jam. Now, All of my lives, if you guys go, because also I have factor sheets and everything in here, and also some other rules and regulations that people need to follow with the math. Like if you can't remember, hey, we have some things with the equation of lines, we have some quadratics, we also have order of operations, properties of exponents. Then we also have our Pythagorean theorem with a little bit of trig, some of the trig identities that's in here. I will be working on a newer version of my book, which will be ready for the start of the school year. I tried to design this notebook for 7th graders up to adult learners. So anyone that's taking like algebra 1, algebra 2, I'm working on one for geometry. And I just really wanted to design a notebook just for math people. And that's the one thing. A lot of the notebooks out there are not designed for math. Like spiral notebooks is supposed to be something that's temporary. You do not want to have your math notes temporary. Okay, you don't want to all of a sudden you got all your notes together and the next thing you know you're missing half your notebook because the spiral thing got unraveled or it got caught on something. So all the binding of it is on Amazon. So I am selling those on Amazon. My math notebooks, I'm actually selling it through my website, as I said, which is on there. And then all of my replays are on my YouTube channel. So if you go to Audrey Codner at ACG Math Tutoring, okay, you can see all the lives that I created since February. So I started going live by February the 5th, and you'll see like the transformation of like, that's an okay video to how we do things now and using all the notes. If you want, you can help me out by doing like a Google review. So at ACG Math Tutoring. And also to subscribe to my YouTube channel so you can get all the latest and the greatest. This live is probably going to go on like around 2 o'clock because sometimes, I don't know, maybe because so many people are on TikTok Live, it always takes forever to download. But that's just my love in life. I will be live tomorrow, but tomorrow's Friday. Fridays I'm live at 1 p.m. So if you can't meet up, that's fine. I always do a recording. And as I said, it will be on my YouTube channel. And then on Saturdays and Sundays, it's going to be 8:30. I'm going to change that. So it's going to be at 8:30. And if you need an online tutor, I do that. Okay. I do have a few students that are going to be skedaddling because they're seniors. But if you're going to need help with your final exam, or you're probably going to be doing some kind of project to do makeup work, okay, you can get some assistance from me, not a problem. I also have an on-demand courses for GED, Accuplacer, ASVAT, and also foundational math. So if some of you guys are homeschool parents and you're looking for another resource, I am thinking about doing a course live this summer and just really using it to help me create an overall curriculum to help support especially people that are going back to school. So when I say I'm going to start from the very beginning, like basically in the beginning of time, this is what happened to numbers, right? And then start talking about fractions and decimals and percents and like doing a lot of the basic arithmetic and then going into the algebraic piece and then going as far as some parts of geometry and statistics. And I really want to do that live. If you think that's a good idea, please let me know. If you think like Audrey, don't waste your time, please let me know. Because I'm doing it not so much, oh yeah, I want to be money grubbing. It's just more so I want to see how I can help more people while I'm still here. I'm not trying to be morbid like I'm about to die tomorrow, but we're all not going to exist forever. So I just really want to make sure that, you know, I can help as many people as I can, especially to overcome this thing called math phobia. It's not hereditary, people. It's a matter of you practicing. It's a matter of you learning how to study math because no one's ever told you. So If you ever get your notes, get a separate sheet of piece of paper. All right, pretend this is a real sheet. Okay, so you got a problem. You copy the problem on the separate sheet of paper. You take your notes, you put it off to the side. You do the work on that separate sheet of paper. Once you're done, that's when you bring the notes back in. And then you use your notes as an answer key. That's how you study math. You can't just be like, oh, I think I know this. Yeah, got it. Yeah, this is great. Yeah, got it. No, it doesn't work that way. Okay? So, let me know. Do I tutor for math SAT? Yes, I do. Just go ahead and message me. Oh, it'll be Eastern Standard Time. Yes, I'm on the East Coast. When did you start doing these math lives? February the 5th of this year. Yep. And it's so funny. Like, I went from maybe one or two people, including you, Michael, and Pog, and there was a different Jen, and there was some other people as well. Yes, Friday at 1 p.m. And then all of a sudden, now we're like in the hundreds. And at one point, a couple of times during early this week, I was like in the thousands. I'm like, wait, what? Did I just say 1.2? Okay. All right, this is crazy. Can you do videos on elimination method? Oh, it should already be on there, Jen. Go to, it should be in my YouTube. It should already be there. Banks! How are you? What? My math teacher quit today and walked off. She said she was done with my class. Wow. Yeah. I felt that way. Especially this time of year, May. She has another job and she's just trying to figure her way out. I trust me. You're welcome. And then Jen, if it's any kind of weirdness or not weirdness, but if you look at the video and you're just like, I still got questions, just reach out. Okay, please. Like, guys, I think I'm approachable. I think I am. I don't know. Sometimes I'm the only one in this house. I can't ask anybody. But for the most part, if there is anything, if you do get stuck, I helped 3 people this week. 3. For the ASVAT. And all 3 passed. Now, I can't take full credit. I really can't. But the fact that, to give people reassurance and motivation to keep moving forward. One person was like, I think I'll just take it later. And I'm like, no, get your head out of your butt and just take it and just get over and done with, because you never know. You might not pass it, but guess what? You get another chance. Why you guys have to be like experts? You're not an expert. Again, you did not just come out the womb ready to like just memorize stuff. And you literally was like, what the hell is this? Oh, it's called a toe. Okay. Guys, give yourself some grace. Is this what our society is doing to y'all? Just stressing y'all out? Like you have to be perfect? Please, take a look around. No one's perfect. The only thing in person that's perfect is God. That's it. Okay? So give yourself some grace. You're here to learn. Try to be in a nice atmosphere. It's okay. All right? I try. How do you find the HA again? Sure. 1 second. Okay, so you always look at the degrees. Okay, so if the degree of the numerator is less than the degree in the denominator, like say for this, my numerator was a 2, my denominator was a 5, that means your horizontal asymptote is always going to be y equals 0. If they are the same, then your horizontal asymptote is going to be y equals whatever your leading coefficients are, which is my 2/3. And for the slant height, happens when the degree in your numerator is bigger than the degree in your denominator, and you will actually have to divide them. Divide the numerator by the denominator. You can do long division. My suggestion will be the synthetic. Okay. If I may, I might go into synthetic division tomorrow, just to have a little bit of extra, if that sounds like a good deal. Bundles of blessings, how are you? Okay, but remember, when you do the synthetic division, your answer, which is right here, is always one less than your original degrees. So if you start off with an x squared, that means this is going to be x. This was your x, that means this is going to be your constant. And this was your constant, that means this is your remainder. Okay? And we'll ignore the remainder. We just need to focus on this, because that is going to be your equation of the slant asymptote. Okay? I'm doing. Things are going. L-dub. I have to take a placement test for math. I want to score high, but I don't remember anything. Okay, when are you taking this placement test? And please don't tell me it's tomorrow. Because I will fly out. And just be like, what are you doing? Will you do one with long, then show synthetic tomorrow? I can do that. Yep, I can do long. I'll do both. Okay. Do you know of any professional that can help look over a personal state? Who is English? English. If anything, message me. Send me a personal message or direct message me. Let me think. Because I do know a few English people, but I would love to know what exactly you want. Because some people specialize in certain things. Okay, the 29th. Okay, I can do that. All right, so Shay, if anything, you can either message me or you can go to my website and fill out that contact form. So we can figure out date, time, and let's see if we can do some stuff. Statement. Okay, thank you. All right. The last part of the question? What question? What did I say? Did I say something? When studying for a final for Algebra 1. For dental school. Oh, okay. Ooh, where are you going? I feel like I forgot many of my steps. And it's for a placement test. So there's a lot of accuplacers that you can look at. I don't want to be like greedy, but why not? This is my platform. Because I did a course for the accuplacer, and it has like 107 videos, has some practice problems on there, have a couple quizzes on there, and it's on demand. So you watch the videos and you can always say, okay, Audrey, I'm stuck on this. And then you just text message me, but probably not like 2:00 in the morning. Who am I kidding? I'm up. That has to stop, but let's be real, I'm up. And then we'll come make an arrangement for like a day that we can meet and just, do maybe not a whole day, but like, an hour, and just be able to tackle like some of the things that you need clarification on. Or best yet, you can possibly, message me and say, hey, Audrey, what are you planning on? But I still stuck, just like how I did today. I wasn't planning on doing asymptotes. Nope. I was going to talk about special triangles. But she was struggling with this, and I was like, all right, let me put it together. All right. And why? Thanks for stopping by. I appreciate it. Yeah, you can. If you want, just go to my website and fill out the contact form, And I'll get all your information and I'll contact you probably tomorrow. Maybe tomorrow morning before I have to mow my grass. Yeah, it's starting to look like Zimbabwe, which is really lovely when the breeze is, but yeah. It's like, I don't know what's out there. Yeah, you're so welcome. Because I understand. I understand that you guys are trying to achieve greatness. Like, you're trying to do something good for yourself. So, you know, I would try to help as best I can. And if I don't know it, I know someone who does. So I always do it that way. All right, so here's a couple other people to follow just in case. All right, if anyone's into nursing and you want to learn how to do your dosage, a blessed RN, she's amazing. And then my friend Evelyn, I think her name is Miss Taylor. So she does the T-test, the AVAT, GED, just like me. But like I always say, it's like I go on once a day because during the day, especially the afternoons, I tutor. And especially this time of year, it's like cray-cray. And schedules are all over the place. And I had student athletes and I have people doing plays and I have people like they're doing dance recitals and all this other fun stuff. So sometimes, like, especially like last night, I was tutoring till 11 o'clock and then I came on here at 11 o'clock. So because I promised that I was going to come on and I'm going to come on. All right. I was half delusional. I don't remember half the stuff that I was talking about, but here we are. But it's always nice to have another person, and she goes live at 1 p.m. Central Time, which is 2 p.m. Eastern Time. So I'll be coming on 1 o'clock tomorrow, and then you guys can jump on her live and do some more practice if you would like. If you need a chemistry tutor, Professor TK, she's amazing. She goes on Tuesdays and Thursdays at 10 a.m. And then my friend Lynette, who is away at science camp this week. I miss her. Hopefully I'll see her tomorrow. But she teaches adding, subtracting, multiplying, dividing using an abacus. So she is really transforming the art of using an abacus and trying to make it a little bit modern, make it more attractive, make it more interesting. And she's doing very well. So definitely follow these guys. Check them out. If there is anything that you ever get stuck on, or like some of you guys are asking me about an English tutor, just let me know. If you're looking for a tutor, if you want to be a tutor, I can help mentor because I've mentored before with how to start your own online tutoring business, because I know a lot of teachers, like that one lady who whose banks teacher just up and left. Hell, if she wants to learn how to do her own tutoring business, I mean, it'll be kind of rough, so she definitely has to go to a school that is not her old because she walked out. I don't think they're going to want to promote her that much. But that's it. General Todd, how are you? I am just wrapping up. Okay. All right. So, I am going to go straighten up. And then I'm going to pass out. And then I'll wake up and I do it all over again tomorrow. So then I will see you tomorrow afternoon at 1 p.m. No problem. No problem. You can come tomorrow. Plus we have the weekend from 8:30. So hopefully everything's going well with you. All right. Thank you guys so much for your time and attention and all the likes. I greatly appreciate it. I really do. I hope everyone is doing well and just keep being awesome. We need more people like you. We really do. All right. Love you guys. Take care. Bye.